Hi. Every year when the students are going to be promoted to IB diploma program, they will always ask me the same question about IB physics. And they will say, hey, Mr. Wong, would IB physics require very good maths? Right? And if I'm bad at maths, can I still choose IB physics? And in this video, I will find out the answer. We'll go and check out the official document from the IBO, and I'll show you a list of what kind of math skills you need to know in order to survive in IB physics. Alright, let's start. Don't worry, this is a big file, but then the list is only on one page. Okay, so don't worry, it's not a lot of maths you need to know. So in fact, this is the whole course of IB physics, and if you really want to read this, you can find it online very easily, and it talks about very general stuff and also a syllabus of IB, including the IB learner profile, and well, this is just table of content, and things like the purpose of the diploma program and how that will be integrated with other parts. Anyway, so the actual list that we are looking for is actually on page 22, I believe. So right here. Okay, so page 22. Alright, so let's start with the first one. Perform the basic arithmetic function. So just plus, minus, times, and divide. I'm sure that you know it. Carry out calculation involving means, finding out the average, so add them up and divide by the numbers that you have. And decimal numbers, of course, fraction is just basically division. Percentage, the fraction times 100%. Ratio, approximation is something that we talk about in chapter 1. So in case you don't exactly know it, I will put the link in the description below, right? That's something that we will talk about in chapter 1. So things like you may be rounding up a number from 9.8 to 10 for some sort of estimation. And also maybe we talk about small angle approximation, where sine theta will be close to theta in radian when the angle is small enough. So like around within 5 degrees. So this is also approximation as well. Reciprocal means like inverse, basically, very simple. Carry out manipulation with trigonometry functions. So basically means sine, cosine, tangent. And that's pretty much it, right? You don't even need to know sine law or cosine law. I never see people use sine law or cosine law in the actual exam. You may find it useful sometimes for your IA, but then it's IA, right? You can take your time to do it and study about it, so you don't have to worry too much. So as for sine, cosine, tangent is more about in a right angle triangle, say A, B, C, you are able to identify sine theta, cosine theta, and tangent theta. So yeah, very simple. The next thing is only for HL. So in case you're SL, then you can ignore it. And this is talking about log function and exponential function. So that is to say, you need to know the basic idea of natural log and also log with the base of 10. Okay, and how that is related to exponential. So things like if you log natural log the exponential e, then it becomes 1. Or when you talk about, say, natural log of both the regular logarithm with base of 10, then it will be like log a times b equals to log a plus log b, things like that. Or if you do divide, then it becomes minus. Or you can talk about log a to the power of b, it will become b times log a, right? So things like that would be required to know for, again, the HL student. Next is the standard notation, and that means, well, I'll call it scientific notation. So expressing numbers with the significance figure and the order of magnitude, 10 to the power of how many. Direct and inverse proportion. So direct proportion means y equal to kx. inverse proportion means y equal to k over x. Next, simple algebra. Solving linear simultaneous equations. So like you have probably two equations. You may need to merge them. You have to rearrange it and substitute into another equation. Again, very simple stuff. Okay, plotting graphs with suitable scale and axis. So if you have been to say IGCSE, I'm sure that you know how to do it. Including two variables that show linear or non-linear relationship. So again, it could be linear, which is a straight line, or non-linear, that means it could be a curve. Next, interpret graphs, and that is to say, including the significance of gradient. So when we say that, that means you can interpret the gradient physically. Okay, of course, like mathematically, when you say, oh, I've got the y-axis to be e and x-axis to be t, then say you somehow have a certain whatever line it is, and then if you try to think about its gradient mathematically, then you know the gradient is delta e over delta t mathematically. And physically, then you can understand its significance in physics, and this is power. Okay, and then change in gradient is a bit different of gradient and change in gradient. Change in gradient means the change of slope, so it's like the rate of the change. So become faster, so like increase with an increasing rate or increase with a decreasing rate, etc. Intercept, that means y and x intercept. And area, again, area could be again the graph with a certain x and y axis. So for example, VD graph, and again you may have a whatever certain line, and so area is like you are doing the integration. But don't worry, you don't need to do integration or differentiation at all in physics. But you have to understand the idea of, say, the area is doing the integration, and physically it actually means like v times t, right? But then of course again it should be integrating it. So you're not required to know how to integrate, but then you need to know the physical meaning of this. In this context would be v times c, that means that will be displacement. Okay, so understanding the mathematical idea first, and then connect that to the physical idea. Next, draw the line of best fit. Again, it could be curved or linear because, like we said earlier, right? On a scatter plot graph. So, like what we learned in chapter 1, when we talk about different error bar, then you will be able to judge the line of best fit. Next, on the best fit linear graph, you can construct the maximum and minimum gradients. So once again, if you don't know what this is, that means you missed out one of our video in chapter 1. So I'll put a link in the description below, you can check it out. And this is with a relative accurate by eye only. Alright, but then I'll say, yeah, you could do it very accurately. Taking into all uncertainty bars, so you have to consider all the error bars. Next, interpret data presented in various forms, so bar chart, histogram, and pie chart. But this is just a guideline. In fact, I really don't think I've seen any bar chart or histogram or pie chart. It's always a scatter diagram. So if anyone, I'm for real, alright, if anyone have seen a bar chart, histogram, or pie chart from the past paper, please leave a comment below. If you can find it out, I probably will give you a secret gift, I think. I really bet there isn't any part like these kind of charts in the past paper at all. Second last, represent the arithmetic mean using x bar notation. So like the number with the bar. So like the average of x, right, with a bar, that means this is average of x. Yeah, it's not even math. I think it's just language. Lastly, express uncertainties to 1 or 2 sig fig with justification. So yeah, this is just a requirement and understanding in chapter 1 also. So normally we express the uncertainty with only 1 sig fig, unless, like I said earlier, you have a uncertainty that's probably is like 0.1 something, then you may use 2 sig fig. Again, if you don't understand why this is the case, or you miss out the video about significant figure, I'll put a link in the description below. And that's it, right? So I don't even call it a lot of maths. I think even if you, well, after you study the first chapter about error analysis, and you know about error bars and max mean line, but other than that, I think you probably have already learned it in junior secondary already. Have you log function? I think you do, right? So yeah, it's actually very simple, even if you do HL physics. In fact, I forget to include one of the exercise questions in the playlist, so I'm going to do it now. And somewhat is related to math requirement, because this one, it will be a demonstration of how to use the log function. Okay, so if you haven't done this question, you can pause the video, try it out first, and I'll show you how to do it.
A few moments later.
Part A. The first question is asking you the initial voltage. So you want to locate when time equal to 0 and this coordinate. But then the problem is this axis is log V, but not purely V. So what you can do to part A is to say when t equals to 0 second, natural log V equals to 4.0. More precisely, because V is like a general idea, so we can say V log to represent V at time t equals to 0. So then if you apply what you learn in maths, that's why we have to understand this, then you should know V log equals to e to the power of 4.0, and so that should equal, using your calculator, there's e if you use this calculator, and to the power of 4, and then I will run it to 2 sig fig, because if you look at this is 2 sig fig, and so 5.5 times 10 to the power of 1 V, that should be the unit. Part B is asking you the time when voltage dropped to half of the original value. So you may just want to find the value directly for a more intuitive way. So then the V that you are looking for, let's call it V half, is going to be 5. Well, I'll use the original value, so 54.598 divided by 2, so about 27.299. And then since the graph itself is in natural log V, so then what you want to do is that when you log this, then you also log the value itself. Okay, I want to keep as much decimal as I want, and then you will be able to find it is 3.306. So let's just keep it as 3.3, because you can't read that much anyway, and you will be able to locate, okay, I'll need to zoom in, you'll be able to locate 3.1, 3.2, 3.3 here, and then all the way draw to here, and then here. Okay, maybe a more narrow pen will be helpful. All right, basically this grid. So this is 5 to 10, and I think there should be 10 grids, so this should be literally 7 seconds, right? 7.0 seconds. So then the corresponding time, you can say that the time for V equals to half, I don't know, like you can phrase it, that's gonna be 7.0 seconds for part B. Part C should probably be the hardest for you, and it's asking you about the resistance. You can see out right here, but then it's hard to determine from the graph or from the equation itself. because you don't have the other values. So what you can do for the beginning would be you have the equation first, just from the question itself, T over RC, and then what you can do is you can take the natural log, and so you have, if I want to do it slower, I can just write this first, and then you know these can be, because this is multiplied, right? So then this could be natural log V log, and then natural log V minus E over RC, right? Or you can do this part fast actually. So I want to do my demonstration, so I'll do a bit slower. And so you know, for the index, you can move it to the front, right? This is like operation you can do with log function. Then that is going to be negative T over RC, and then leaving you with natural log E, and this in fact is just equal to 1, so you can just ignore it. Not 0, by the way, it's different, right? 0 and 1 is totally different. It equal to 1, so you still get to keep negative T over RC here. So if you try to see this, then one interesting thing is you will find out natural log V is going to be the y-axis of this graph, and then the T, this one, is going to be the x-axis of this graph. So if you try to think about, this is a linear line once again, so y equal to mx plus c is a form that I think you are familiar with. C is the y-intercept, m is the slope, and if you try to see it this way, then obviously the y-intercept c from this equation is going to be natural log v log. However, this is not nothing I will be interested right now, but then we will be able to find the slope m to be this one. Alright, maybe I can write here. So this is going to be m, and so that means as long as we can find out the slope of this graph, then the slope or the gradient will equal to negative 1 over RC. And because the question already told you about C, which is the capacitance, whatever that is, C is 5 mu F. And so if you have the slope, if you have the C, then you can find out. So I don't have space, so allow me to write here. For the slope, it's going to be delta y over delta x. Alright, just to write general formula for you. Then you can have this point, which is 4.0 and 0 for x, minus this point. This point is going to be y for 0 for y, and x gonna be 20, and so the slope is basically 4 divide negative 20. That is, well, negative 1 over 5, and you can simply connect that with minus 1 over RC, right? That is what we deduced earlier. And then let's just present it here. So therefore we have 5 equals to RC, and C, according to the question, is 5. Mu is 10 to the power of negative 6, and so R is going to be 5 and 5 will cancel, so R is simply 10 to the power of 6 ohm. That would be the final answer. So in fact, this is a very good exercise for you to work, and this may be something that you will need to do similarly in your IA as well. No! 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 Oh my god, I make a mistake. I got thick by the diagram. This is not 0. This is not 0. This is actually 2.0. Okay, so this is not a good practice, by the way, right? Normally when you want to present a graph in physics, we usually keep the origin as 0, 0. Okay, or if you really want to do this, then you may want to use the broken line to to present like this. Alright, so this is a bit misleading. Alright, not totally my fault, okay? And so the answer would then be changed to 2 over -20, and so here that should be -1 over 10, and so I would be able to change 10 here, we cancel 2, so this should be 2 times 10 to the power of 6 ohm instead. So this is the correct answer instead. Alright, so in this video I hope you understand we don't really require you to know a lot of maths in advance. So pretty much all the things that you need, you have learned it already. And rather, I would say the most important thing is like how I just demonstrated. You have to be careful in your calculation. So I would rather say that's more essential in your experiment. I hope you enjoy learning with me. My name is Mr. Wong. I will see you again in the next video. Bye.